Hey, what's going on, Chem 30s? Today we're going to be doing a redox table example. So what we want to do is we want to build a table of reduction half reactions based on the evidence given here in these three reactions. Now, things I want you to keep in mind is just look at the first reaction and label the oxidizing agent and the reducing agent. And in order to label the oxidizing agent or reducing agent, you should be able to remember the only word you need to know is Garoa. There we go. So Leo the Lion says Garoa, and what that means is the oxidizing agent. The oxidizing agent gains electrons and undergoes the process of reduction. So what we're going to do is we're going to take a look at this first reaction here, and we're going to label the oxidizing agent. So cobalt starts as 2 plus and ends as neutral while it's becoming more negative, and that sure sounds like it's gaining electrons. So I'm going to label it as the oxidizing agent. If it's the oxidizing agent, then indium must be the reducing agent. Nice. So now what I want to do is I'm just going to place cobalt kind of down here on the left-hand side. So I'm going to put cobalt 2 plus aqueous. And what I want to know is cobalt 2 plus and solid indium, they made a spontaneous reaction. Spontaneous reactions are downhill in your table of reduction half reactions. So in order for this to be downhill, in order for this to be spontaneous, right, cobalt 2 plus and indium has to be somewhere over here. So should it be below or should it be above cobalt? Well, in order for it to be downhill, it's got to be below. So I'm going to put indium down here, and I'm just going to fill in the remainder. So the cobalt half reaction is higher because it's better at stealing electrons. So it turns into cobalt solid, and indium turned into indium 3 plus. Perfect. So those aren't complete half reactions yet, but we're just kind of building up for the idea. So the idea here is cobalt 2 and indium, cobalt 2 and indium, they made a downhill reaction. And that's exactly what we wanted to see from our table. Okay, let's keep going. Reaction number 2 has copper 2 plus and palladium. Now, I don't see copper and I don't see palladium anywhere in my table. So what I'm going to do is I'm just going to skip this reaction for right now, and I'm going to go to the next reaction. So we got copper 2 plus. Okay, I still don't have copper 2 plus, but I do have cobalt. So look at cobalt here and think to yourself, okay, the cobalt solid is here, and if copper 2 plus and cobalt made a spontaneous reaction, should the copper 2 plus, the copper 2 plus has to go on the opposite side of cobalt, right? If copper 2 plus and cobalt are potentially reacting with each other, they have to be on opposite sides of the table. So if one's on the right, then the other is on the left. So in order for it to be a spontaneous reaction, it has to be downhill. So we have to put copper 2 plus above cobalt. So I'll erase that. Good, perfect. So now we had copper 2 plus and cobalt making a downhill reaction. Fantastic. So we finished the first reaction, we finished the last reaction, and now we're on to the second reaction. So we're looking for copper 2 plus and palladium. Okay, well, copper 2 plus we have. Copper 2 plus is right here. And it's not reacting with the palladium. It's forming a non-spontaneous reaction. So that means the palladium and the copper 2 plus have to be uphill. This has to be an uphill reaction. So I'm going to put the palladium up here, and then the palladium 2 plus ions can go here. So I've made a table of reduction half reactions. And now, if I wanted to, I could rank the oxidizing agents or the reducing agents, right? So on the left-hand side here, we've got oxidizing agents, and on the right-hand side, we've got reducing agents. I could rank them from strongest to weakest if I wanted to. So the oxidizing agents from strongest to weakest, right? And we've got 4 here. So up top, palladium 2 plus is the strongest oxidizing agent. So palladium 2 plus, copper 2 plus, cobalt 2 plus, and then finally indium 3 plus is the weakest oxidizing agent. And we could do the exact same thing for reducing agents, except the strongest reducing agent is over here. Anyways, hopefully that helped a little bit. Let me know if you have any questions. I'll see you later.